Hello children, in this lecture we will discuss some thermodynamic quantities, and out of these quantities there are internal energy which is represented as U or delta E. So now internal energy is represented with the help of U only. Work, heat, enthalpy represented with the help of H, entropy represented with the help of S, free energy with G, etc. These are the thermodynamic quantities, and we will discuss all these quantities one by one. Okay, so first we will start with internal energy or internal energy change. So we all know that every substance is associated with definite amount of energy. It depends upon its chemical nature, temperature, pressure and volume. Okay students, so the internal energy of a system or a substance is a definite quantity. It is a state function. So state function quantities are the quantities which don't depend upon the path. Okay, so quantities which depend upon the state only are known as state function quantities. So according to this definition of internal energy, all the substances are related with a particular amount of energy, and which is further depend upon the chemical nature, temperature, pressure and volume of the substance or the system. Okay students, so this internal energy is actually present in the substance in the form of number of different type of energies, and these are the energies as translational energy, vibrational energy, rotational energy of the molecules, electronic energy, nuclear energy, molecular interaction energy, etc. So these all energy together are responsible for the internal energy of the substance. Okay, so we can say that the total amount of energy associated with the fixed amount of a substance under a given set of conditions is referred to as the internal energy or intrinsic energy of the substance. Okay students, so according to definition which is given in your book, energy is stored within a substance or a system is called its internal energy, which is represented as U with the help of U, and internal energy of the substance or internal energy of the system. Now we will discuss change in internal energy. So change in internal energy is represented with delta U, and it is important to know that the actual value of internal energy is not determined. We cannot determine actual energy of any system, internal energy of any system or substance, because these all different energy forms which are given here, like rotational energy, translational energy, electrical energy, mechanical energy, these all energies of the substance or the system are interconnected. So the actual internal energy of a system cannot be determined. So it is the change in internal energy accompanying a thermodynamic process which is determined. So the change in internal energy is becoming more important because this we can determine. Okay, so for determination of internal energy change, suppose a system is in initial state A and comes in final state B, which is given here. from initial to final state. Now internal energy in initial state is U1 and in final state it is U2. So the change in internal energy delta U will be equals to internal energy in final state minus internal energy in initial state. So U2 minus U1. Okay, so U2 final state internal energy. So we can represent in this way also. Delta U will be equals to internal energy of the product minus internal energy of the reactant. Okay, so for a general change we can write delta U equals to internal energy in final state minus internal energy in initial state. Okay, students. After this, the following methods may be used to change the internal energy of the system. So these are the ways to change the amount of internal energy of a system. So according to this first point, if heat is supplied to the system or heat is taken out from the system, by this we can do change in internal energy of the substance or the system. Second point, by doing work on the system or by the system. This is the second way with the help of which we can do a change in internal energy of the system. And the third is matter enters or matter leaves the system. Okay, students. So these are the three different ways to with the help of which we can do change in amount of internal energy of a system. Now we will discuss sign for delta U, change in internal energy. So if the condition is such in which internal energy of reactant is greater than of the product, then the sign of the internal energy will be negative, because overall heat will be produced, means system will produce heat. So the sign of the change in internal energy will be negative. And if the condition is reverse, in which internal energy of the reactant is less than product, then in this change energy will be absorbed and the sign for the change of delta U will be positive. Okay, students. So in short, if delta U is negative, energy is released, and if it is positive, energy will be absorbed. Okay, the next is work. So such systems, for example, if some hot water is in thermos flask, then thermos flask does not allow exchange of heat between the system and surrounding, and this type of systems are known as adiabatic systems. So the process by which the state of this type of system is changed, state from initial to final. So such changes are known as adiabatic process. Okay, so if the state of adiabatic system is changed, so the changes which will be done with the help of process will be known as adiabatic process. There is no exchange of heat between the system and surroundings in adiabatic process. So the wall of the system which are separating system from surrounding are known as adiabatic walls. Okay, so in such systems we can do change in the state by two ways, with the help of change in temperature. Okay, so how can we change in temperature? With the help of two ways. One way, by churning of the water with the help of a paddle, and the second way by putting an electrical immersion rod. So due to these two ways, we can change the temperature of the system. Let the system is A. So with the help of these two ways, we can change the temperature of the system. So let if initial temperature of the system is TA and internal energy is UA. Okay, now we can bring the system in state B where its temperature and internal energy is TB and UB respectively. So these changes will be done with the help of out of any one way of the following. Okay, so after the change, the temperature TB will be greater than TA. So this is the TA's initial temperature and TB is the temperature after such doings. Okay students, so in that condition, change in internal energy will be equals to UB minus UV. It will be equals to adiabatic work, or delta T will be equals to TB minus TA. So the internal energy is a state function and the adiabatic work is equal to the delta U. Similarly, the change in temperature delta T is also a state function. It does not depend upon the method and path by which the temperature has been changed. And same way, volume of the water is also a state function. Then there are two types of work with the help of which we can change in the state of the system. So two types of work, first is electrical work and second is pressure volume work. So electrical work we can do with the help of electricity, for example electrolysis. So electrolysis is an example of electrical work. And pressure volume work, this type of work is involved in system containing gases. Pressure volume work is a mechanical work. It is that work when the gas expands or compressed under the condition of the pressure. So gas will expand when the pressure outside will be less than the pressure inside of the system, and gas will compressed when the pressure outside will be greater than the pressure inside the system. So work done in compression or expansion. This type of work is related to gases in which the volume of the gases change under the external pressure. Okay, so when the gas expands, work is done by the gas and the sign of work W is negative, as you can see here. And if when the gas compressed, the work is done on the gas, and in that condition W will be positive. Okay students, so pressure volume work will be equals to pressure into change in volume. So P into delta V, this will be the pressure volume work. Okay, now if this pressure volume work is done by the system, then the sign will be negative. Sign will be negative for the work. Okay, and if the work is done on the system, then the sign of the work will be positive. In that condition, W will be equals to P delta V, positive. Okay students, so positive work means work on the system will be done when the external pressure is greater than the internal pressure of the system. And if the opposite condition is there, internal pressure of the system is greater than the external pressure, then the work done by the system on the surrounding, and in that condition W will be equals to minus P delta V. Okay, students. The next heading is heat. So, the internal energy delta U of a system can be changed by transfer of the heat from the surroundings to the system or from the system to the surroundings without expenditure of work. Okay, so suppose we take some water in a container made up of copper whose walls are conductor in nature. The copper container is placed in a huge heat reservoir at temperature TB. Then suppose the temperature of water in copper container increases from TA to TB, then it means the heat is taken by the container from the surrounding. Okay, and in that condition the change in internal energy will be equals to Q. Okay, students, because heat is taken by the system from the surrounding, and if the reverse condition is there, that heat is given by the system to the surrounding, then delta U will be equals to minus Q. Okay, students, so as you can see from here that if heat is absorbed by the system, then Q is positive. If heat is given out by the system, then Q will be negative. Work done on the system positive, work done by the system negative. Energy of the system increases, then delta U is positive, and energy of the system decreases, then delta U is negative. So you have to keep these sign in your mind. Okay, so if a gas expands, then V2 will be greater than V1. V2 is final volume and V1 is initial volume. In this condition, work is done by the gas. Therefore, W is negative. And if a gas contracts, means V2 is less than V1. So V2 is final volume and V1 is initial volume. In that condition, work is done on the gas and W will be positive. Okay, students, thank you.